Hello, it's Miss Stone with you again today. Today we're talking about the rational root theorem again. This is day 2. We have a polynomial function and we want to know what our zeros are, but our zeros are not nice, pretty numbers, but we know that they are fractions. So our first example, we have f of x is equal to 6x cubed minus 5x squared plus 54x minus 45. We want to know what are the possible rational zeros. So the rational root theorem allows us to take the factors of 45 right here and all over the factors of 6. And when we do that, our factors are plus or minus 1, 3, 5, 9, 15, and 45. And plus or minus 1, 2, 3, and 6. And then all of our possible zeros, we get plus or minus 1, 3, 5, 9, 45, and so forth. Again, we take each one. So we would do 1 over 1, 3 over 1, 5 over 1, 9 over 1, 15 over 1, and 45 over 1. And then we can move over. We get 1 over 2, 3 over 2, 5 over 2, 9 over 2, and we continue on. Again, I took out all of the values that we're repeating. Okay, so now we reviewed how we got those answers. Now we should put it into our calculator. Let me see here. Trying to. All right, there it is. So what should we test in our calculator? So go ahead and plug this into your calculator. Pause it if you need to. And when you plug it into your calculator, you should get something that looks like this. This is what your graph should look like. Okay, now looking at our x-axis where our zeros are, I see that it crosses right really close to 1, but not quite to 1. So looking at all of our values, we want to know, hold on, which one is really close to 1, but not quite at 1. If you notice, 5 over 6 is really close to 1, but it's not quite 1. So we're going to test 5 over 6 in our calculators. And to do that, we go second calc, and we hit 0. And then we just type in 5 over 6. And when we do that, we should get y is equal to 0, telling us that 5 over 6 is, in fact, a 0 of this polynomial function. Next, we need to use synthetic division to get our other two zeros, because we know that I should have 3. All right, so synthetic division, we're going to use 5 over 6. I have 6, negative 5, 54, and negative 45 for my equation, or my polynomial. So synthetic division, I pull down the 6, and then I have 5 over 6 times 6, which just gives me a positive 5. Negative 5 plus 5 gets me 0. Anything times 0 is 0. So we have 54 plus 0. And then I have 54 times a 5 over 6, which gives me a 45. And I have negative 45 plus a positive 45. So my remainder is 0. And that's what it should be, because we said that 5 over 6 is, in fact, a 0 for our function. All right. So now with synthetic division, we get 6x squared. I don't have an x with a 0, or I don't have a number, so I don't have any value with an x here, and I have 54, and then I set it equal to 0. And when I do that, I can move my negative 54 over and divide by 6 by both sides to give me x squared is equal to a negative 9. When you square root both sides, we get x is equal to plus or minus 3i because of my negative here. So my zeros for this polynomial function is 5 over 6 and plus or minus 3i. Those are my 3 zeros. Let's go ahead and take a look at another example. So I want to find my zeros for 5x cubed minus 9x squared plus 28x plus 6. So what are my possible rational zeros? Using the rational root theorem, I can take my factors of 6 over my factors of 5. And when I do that, I get 1, 2, 3, and 6, and 1 and 5. So my possible zeros are plus or minus 1, 2, 3, 6, 1 over 5, 2 over 5, 3 over 5, and 6 over 5. All right, so what should we test in our calculator? Go ahead and type that into your calculator. Pause it if you need to. All right, so your graph, and I made a little rough one over here, should look something like this. If you notice, we have a 0 or an x-intercept right here, just right to the left of 0, so I know that it's going to have to be a negative. So looking back at your options, which one is really close to 0 but negative? So I noticed that 1 over 5, that's really close to 0. So that's what we're going to test in our calculator. You're going to type in negative 1 over 5. Remember, we hit second calc, 0, and then you're going to type in negative 1 over 5, and we should get that y is equal to 0. All right, so you should get that. So that means that negative 1 over 5 is a 0. So now we're going to use synthetic division to get down to x squared. So when you use synthetic division here, I got down to 5x squared minus 10x plus 30 is equal to 0. I took out a 5 on both sides to get down to x squared minus 2x plus 15. And then I have 0 divided by 5, which is still 0. So you're going to have to use a quadratic formula. Whoops, that was an accident. So I didn't type that all on here because that would be challenging, and I'm still trying to figure out how to type in math equations. As you can see, I just drew a square root. But when you do that, you should get 1 plus or minus I square root of 29. So your 3 zeros for this polynomial function are negative 1 over 5 and 1 plus or minus I square root of 29. All right, so that was a quick review of using the rational root theorem to find our zeros. Go ahead and start on your homework. And if you notice, I was nice, and this is one of the homework problems. So, you're welcome.